let's look at what we mean by a bounded monotonic sequence. A bounded sequence means that it is both bounded above and below. So a sequence is bounded above if there's a real number m, such that a sub n is always less than m for all n. This is our upper bound. While it is bounded below if there is a number n, can't talk and write at the same time, such that n is less than or equal to a sub n for all n. So if my sequence does something like this, then we say it is bounded. Now, a bounded monotonic sequence converges. So let's look at what that might look like. Suppose we have an upper bound and the sequence is monotonic. So it's, in this case, it's going to always be increasing, but it is going to be, but this is the upper bound. Then we see that it's got to converge. As opposed to, suppose we have a lower bound. So this is my lower bound. If it is bounded but monotonic, we see it also has to converge. So let's look at this sequence right here. A sub n is 1 over n. Well, it's bounded, clearly. It's bound by 0 and 1. If I look at the terms, it's 1, 1/2, 1/3, 1/4, etc. So it's clearly bounded. Now let's see if it's monotonic. So let me see if 1 over n, now I see that they're decreasing, so let's see if this is always true. So I'm going to see if 1 over n is greater or equal to 1 over n plus 1. So cross multiply. So is 1 always greater than or equal to 0? Yes. So it is monotonic. So by definition, or by the theorem, a sub n converges. Let's look at this sequence right here, b sub n. Let me look at the limit as n approaches infinity of n squared divided by n plus 1. Well, this is infinity. It is not bounded. Therefore, it does not converge. It is monotonic, but it kind of shoots off there. Now, let's look at this sequence right here. C sub n is minus 1 to the n. This one just bounces around between -1, 1, -1, 1. It's bounded, but it's not monotonic. So this sequence does not converge.